You're sitting on a commercial flight cruising over the ocean, and the pilot comes on the speakers to announce that your ground speed is exactly 480 knots. Not miles per hour, knots. That translates to roughly 550 miles per hour. But the terminology raises an obvious question. Why are the most advanced machines on the planet using a unit of measurement that sounds like a maritime tradition? To understand why, we have to look at the alternative. The standard mile you see on your car's speedometer is a historical accident. It originated as exactly 1,000 paces of a Roman soldier. That arbitrary length functions perfectly when you're driving down a highway. You have fixed landmarks, exit signs, and solid ground to measure physical progress against. Terrestrial navigation relies entirely on an artificially filled environment. Miles per hour is a system built for a world where you always have surroundings to reference. But now, strip all of that away. Imagine you're a sailor in the 1500s. No GPS, no landmarks. You're navigating a complete visual vacuum with nothing but moving water in every direction. In this environment, a slight miscalculation in your speed has life or death consequences. If your numbers are off, you miss entire coastlines, and your crew starves to death looking for land. The earliest attempt to build a maritime speedometer was desperate. Sailors would throw a loose piece of wood off the front of the ship, run alongside it toward the back, and simply guess their speed based on how fast it passed them. Measuring speed inside a featureless void requires an entirely different technological approach. You can't rely on visual landmarks because there are none. In 1574, someone finally figured it out. They tied a wooden board to a long rope and tied physical knots into that rope spaced exactly 47 feet and 3 inches apart. The sailor threw the board off the back of the ship to grip the water and let the rope unspool in their hands, timing the action against a highly precise 28-second sand glass. This specific ratio of rope length to time produced a 1-to-1 result. If 6 knots slipped through your fingers before the sand ran out, your ship was traveling at 6 nautical miles per hour. You were literally doing 6 knots. Look at these handwritten columns. That wooden board gripping the water was called a log. When captains recorded these specific speed readings, they wrote them into a logbook. This crude trick with a piece of wood and some rope solved 16th century navigation, and it left a permanent mark. Every time you log in to a computer, you are using the vocabulary of a maritime speedometer. Take a look at this 3D wireframe of the Earth. To understand why those sailors used exactly 47 feet and 3 inches of rope, we have to look at the macrogeometry of the planet. Navigators divide the Earth into 360 distinct degrees. Each degree is divided into 60 smaller increments called minutes. The globe is wrapped in 21,600 slices. 1 nautical mile equals exactly 1 minute of latitude on the Earth's surface. Look closely at the strict latitude grid lines on this navigational chart. If you are traveling at 10 knots, you know instantly that in exactly 1 hour you will cross 10 minutes of latitude on this specific grid. The nautical mile is a physical piece of the planet, allowing the map, vessel speed, and the Earth itself to speak the identical mathematical language. Fast forward to the early 1900s. The inventors of the first airplanes faced a critical choice. They could measure their speed using car-like miles per hour, or they could look back to the sea. Early aviators quickly realized that the sky behaved exactly like the open ocean. They were crossing massive, empty spaces, entirely devoid of road signs, milestones, or fixed landmarks. So aviation quietly rejected terrestrial measurements. They looked to maritime history and borrowed the sailor's entire toolkit: the maps, the latitude grid, and the knot. Environments dictate technology. Because the ocean of water and the ocean of air present the exact same geometric problems, they require the exact same geometric solution. In 1929, at a conference in Monaco, the international community officially locked the nautical mile at precisely 1,852 meters. Today, the knot is the universal standard mandated by the United Nations aviation body. Pilots, air traffic controllers, and meteorologists all over the world use it to communicate wind speeds and flight paths without the need for mid-air math conversions. The idea that the knot is an outdated superstition is backwards. Miles per hour, a unit based on the arbitrary footsteps of Roman soldiers, is the historical accident. When a commercial pilot announces your speed in knots, You are listening to a 400-year-old measurement that survived because it is the only system that forces the machine, the map, and the planet to perfectly agree.